Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read a question. It says that using Biot-Savart's law, derive the expression for the magnetic field in a vector form at a point on the axis of a circular current loop, and then the B part, that is what does a toroid consist of. Find out the expression for the magnetic field of a toroid for n turns of a coil having the average radius r and the current I. Alright, so first we have to derive the expression from the magnetic field along the axis of a circular loop. So for that we will first have to draw a loop. Very important, we have to consider the diagram. So let's just take this as a loop. Alright, so that's a loop and it is having a radius of capital R. So it is like perpendicular to the surface. This loop is actually perpendicular to the surface, and then we have to find the magnetic field at point P, which is a distance of x. So let us draw this distance, which is going to be equal to small r, that is under root of x square plus r square. Now let us consider the small length element xy, which is having a length of dl. Alright, let's take this point as C, this point as O. Similarly, just opposite, or we can say diagonally to this point C, we take another portion of the length element x dash y dash. So that's going to be something like this, and we will take this angle as theta. Alright, so because of the first element here, it is going to be dB. So this component getting splitted up is dB cos theta, and this component is going to be equal to dB sin theta. Similarly, because of the element x dash y dash, dB would be somewhere here, taking this angle to be theta. So that's going to be dB cos theta, and that's dB sin theta. So very important here is the diagram. So now, according to Biot-Savart's law, magnetic field due to the small element dl at x, y at point P is equal to dB is equal to mu naught upon 4 pi I dl sin phi upon r square, where phi is the angle between I and dl, that is this element dl and phi. So that's an angle phi here, because it is always 90 degree, because as I have told you earlier that the plane of this loop is perpendicular to the surface. So phi is 90 degree, therefore sin phi is equal to 1. Therefore this component dB is equal to mu naught upon 4 pi I dl upon r square. Now resolving dB into two parts, dB cos theta and then dB sin theta. So this dB cos theta is perpendicular to the axis of the plane, axis of the coil, and dB sin theta is along the axis of the coil and away from the center of the coil. So here we can say that all the dB cos thetas for all the points of the coil will get cancelled out, and we will be left with the summation of dB sin theta. Therefore the total magnetic field B would be equal to integral of dB sin theta. So just putting in the value of dB, which we have just calculated here. So this dB integral of mu naught upon 4 pi I dl upon r square sin theta. So we can just taking out the constants, mu naught upon 4 pi is a constant, and then I, then r square, and also sin theta. So we are just left with an integral of dl. So what's going to be an integral of dl? Because we're talking about the total length of this coil, so it's going to be 2 pi r, that is the circumference. And also in the next step we can keep the value of sine theta, which is equal to perpendicular upon hypotenuse. So we just have to put in the values in here. So it is mu naught I upon 4 pi r square, the value of sine theta, that is r, upon under root of x square plus r square into the value of integral of dl, that is 2 pi r. So now can we take this value of r square as equal to x square plus r square? So it would be something like mu naught I r into 2 pi r. Okay, now one more thing, I should take it as 2 pi capital R, right? Why? Because we're talking about this coil, so it is going to be, the radius of this coil is capital R, so we're going to take it as capital R. So mu naught I r square is something that we can write down as well, and then we have 2 pi and 4 pi r square. Okay, instead of r square we were supposed to write x square plus r square, and then under root of x square plus r square that we were already having. So the finally we can write it as mu naught upon 4 pi and then 2 pi r square I upon x square plus r square to the power of 3 by 2. Now you must be wondering why I am not cancelling this 2 pi and 4 pi. That's because we are already knowing the value of mu naught upon 4 pi, which is 10 to the power minus 7. So if we are cancelling it, we are basically increasing the complications for ourselves. So just pay attention to these small details and then physics will get much simpler. So thank you so much for your time. Now we are left with the B part. So let's discuss about the B part now.